Elixir School. Debugging. Bugs are an inherent part of any project. That's why we need debugging. In this lesson, we'll learn about debugging Elixir code as well as static analysis tools to help find potential bugs. Dialyzer and Dialixir and Dialyzer. The Dialyzer, a discrepancy analyzer for Erlang programs, is a tool for static code analysis. In other words, they read but do not run code and analyze it, e.g., looking for some bugs, dead, unnecessary, or unreachable code. The Dialixir is a mixed task to simplify usage of Dialyzer in Elixir. Specifications help tools like Dialyzer better understand your code. Unlike documentation, which is human readable if it exists and is well written, the spec tag uses a formal syntax better understood by tooling. Let's add Dialyzer to our project. The simplest way is to add dependency to mix.exs file. Then we call mix-steps-git, mix-steps-compile. The first command will download and install Dialixir. You may be asked to install hex along with it. The second compiles the Dialixir application. If you want to install Dialixir globally, please read its documentation. The last step is to run Dialyzer. To rebuild the PLT, persistent lookup table. You need to do this every time after installation of a new version of Erlang or Elixir. Fortunately, Dialyzer will not try to analyze the standard library every time you try to use it. It takes a few minutes for the download to complete. Mix Dialyzer -plt. Static analysis of code. Now we're ready to use Dialixir. So mix Dialyzer. Invalid type specification for function Elixir examples sometimes 1. The success typing is _number. The message from Dialyzer is clear. The return type of our function sometimes 1 is different than declared. This is because enum sum1 returns a number and not an integer, but the return type of sum times 1 is integer. Since number is not integer, we get an error. How do we fix it? We need to use the round1 function to change our number to an integer. Finally, mix Dialyzer. Passed successfully. Using specifications with tools to perform static code analysis helps us make code that is self-tested and contains less bugs. Debugging. Sometimes static analysis of code is not enough. It may be necessary to understand the execution flow in order to find bugs. The simplest way is to put output statements in our code like io_puts_to to track values and code flow. But this technique is primitive and has its limitations. Thankfully for us, we can use the Erlang debugger to debug our Elixir code. Let's look at a basic module. So example, CPU burns ABC, then run IEX and run debugger. So we have Erlang debugger.start. The Erlang debugger module provides access to the debugger. We can use the start1 function to configure it. An external configuration file can be used by passing the file path. If the argument is local or global, then debugger will, if it's global, debugger will interpret code on all known nodes. This is the default value. Local. Debugger will interpret code only on the current node. The next step is to attach our module to the debugger, or attach our debugger to the module. Elixir int or an interpreter dot ni. Ni. What does this ni thing do? Ni example. The int module is an interpreter that gives us the ability to create breakpoints and step through the execution of code. When you start the debugger, you will see a new window like this. After we've attached our module to the debugger, it will be available in the menu on the left. Creating breakpoints. A breakpoint is a point in the code where execution will be halted. We have two ways of creating breakpoints. int.break2 in our code, or the debugger's UI. Let's try to create a breakpoint in IEX. So we have int.break, and then our module, and then the line number. This sets a breakpoint on line 8 of the example module. Now when we call our function, example CPU burns 111, execution will be paused in IEX, and the debugger window should look like this. An additional window with our source code will appear. In this window, we can look at the value of variables, step forward to the next line, or evaluate expressions. Int disable break2 can be called in order to disable a breakpoint. Int disable break, and then example and the line number. To re-enable a breakpoint, we can call int enable break2, or we can remove a breakpoint like this. Delete break. The same operations are available in the debugger window. In the top menu, break, we can select line break and set up breakpoints. If we select a line that does not contain code, then breakpoints will be ignored, but it will appear in the debugger window. There are three types of breakpoints. Line breakpoint, debugger suspends execution when we reach the line, set up with int break2. Conditional breakpoint, similar to the line breakpoint, but the debugger suspends only when the specified condition is reached. These are set up using int getBinding2. Function breakpoint. Debugger will suspend on the first line of a function, configured using breakin3. That's all. Happy debugging. Debugging techniques in Elixir. So IO puts to IO inspect, debugger, IEX pry. So we can do this, or we could do it on one line, require the IEX, and then IEX pry. IEX pry 0 is built on top of IEX. Although it isn't a traditional debugger, since you can't step, add breakpoints and so forth. Well, that's useless. If you need a breakpoint feature, we can use the debugger module that ships with Erlang. Let's make a change. Now we can start debugging with debugger start, and this knee, the nights that say knee. Yeah, we just saw that. Anything else in here? No? Well, How about in here? IO inspect with binding. Binding 1 is very useful when you want to see all variable names and values of the current function. Apex. Apex is a lib worth mentioning, especially because of its adef method. Apex test. Change def to adef. It's adef macro. So we have IEXPRI again, debugger again, sysGetState, and sysGetStatus. That's kind of neat. Wow. Ooh, replace state. Process info. It's also nice. Systrace. Trace process calls. Distillery commands. Observer. Observer.start. Huh. Alright, I'll be back.